Good morning, class. Welcome back to Grade 4 Maths. How are you all doing today? So I hope you all are clear with the concepts we learned in Chapter 5. So today we'll do the questions from Revision Station, which is in page number 77 of your textbook. Let's see the first question, and you have a set of questions there. Let's see the first question. The question A, 15 and 20. So which are the factors of 15 and 20? The factors of 15 are 1, because 1 into 15 is 15, then 3 into 5 is 15. So the factors of 15 are 1, 3, 5 and 15. And the factors of 20. Factors of 20 are 1, 2, 4, 5, 10 and 20. So here we have the factors of 15 and 20 listed. Now, do you see some common factors here? 1 is common. 5 is common. Any more common factors? No. So the common factors for 15 and 20 are 1 and 5. And you have a few more questions with the question number 1. You have to work out the remaining questions in your notebook. So let's move on to the question number 2. Find out if the first number is a factor of the second. If yes, put a tick or else put a cross. So what is given in the question? You are given a set of questions, and in each set you can see two numbers. A pair is given. You have to check if the first number, for example in this case 5, you have to check if 5 is a factor of 65, and if yes, you have to put a tick, and if no, you have to put a cross. So let's see 5 and 65. So what is the divisibility rule for 5? For a number to be divisible by 5, it has to end with, or the one digit should either be 5 or 0. And we know factors of a given number are those numbers which can divide the given number completely without any remainder. So is 5 a factor of 65? Yes, the one digit here is 5. So the 65 will definitely be divisible by 5. Means 5 will be a factor of 65. So let's put a tick mark here. You have a few more questions there. Let's see the next one, 3 and 16. So what about 3 and 16? Is there any multiple of 3? Is there any other number which can be multiplied to 3 to get the number 16? No, right? So 16 is not a multiple of 3, or 3 is not a factor of 16. So let's put a cross over there. 3 is not a factor of 16. Now what about question C, 9 and 55? Is 55 a multiple of 9? No. So 9 is not a factor of 55. So let's put a cross over there. Now what about D, 8 and 56? We know 8 sevens are 56. So 8 is a factor of 56. So let's put a tick there. Now question E, 6 and 30. 6 5s are 30. So 6 is a factor of 30. So let's put a tick over there. Now question F, 3 and 69. And is 3 a factor of 69? Is there any number which can be multiplied with 3 to get 69? Yes, we know 23. 3s are 69. So 3 is a factor of 69. So let's put a tick over here. Now what about question G, 7 and 64? 64 is not a multiple of 7, or 7 is not a factor. We cannot divide 64 with 7 completely without any remainder. So let's put a cross over here. Now what about question H, 4 and 28? 4 sevens are 28. So 4 is a factor of 28. So let's put a tick over here. So that was question number 2. Let's move on to question number 3. Find the first 10 multiples of the following. And the first question is 2 and 4. So multiples of a number. What are multiples? Multiples of a number are obtained by multiplying the given number by numbers such as 1, 2, 3, 4, etc. So the multiples of 2, let's see here. You are asked to write the first 10 multiples. So the first multiple 2 means 2 1s are 2, 2 2s are 4, 2 3s are 6. Similarly, up to where the first 10 multiples means 2 into 10, or 2 10s 20. So here we have the multiples of 2 written, and the first 10 multiples of 4, 4, 18, 12, 16, and goes on till where 4 10s are 40. So these are the multiples of 2 and 4. Similarly, you have a few more questions for the question number 3. Please do complete the questions in your notebook. Let's move on to question number 4. Find the LCM of the following pairs of numbers. And the first question is 8, 9 and 33. So how do we find the LCM? What is LCM? LCM is the least or the lowest common multiple of the given numbers. So let's first see the multiples of 9 and 3. Which are the multiples of 9 and 3? Let's see a few multiples. Multiples of 9. 9 ones are 9, 9 twos are 18, 9 threes are 27. Goes on. Here we have a few multiples listed and a few multiples of 33 are also listed here. 33 ones are 33, 33 twos are 66, 33 threes are 99 and so on. So do you see common multiples here? See any common multiple here? This 99 is a common multiple. Is there any other common multiple? There may be higher numbers or higher multiples which will be common to 9 and 33, but the lowest or the least common multiple of 9 and 33 is 99. So we write that LCM of 9 and 33 is equal to 99. Similarly, please complete the rest of the questions from the question number 4 in your notebook. Now, let's see the next question. Fill in the blanks. You have a set of 5 questions there. In the first question, the largest factor of any number is the dash itself. So when we learned about factors, we learned that for all numbers, 1 will be a factor and the number itself will be a factor. And all the other factors will be numbers that will come in between this 1 and the number itself. So if that is the case, which will be the largest factor of any given number? For any given number, the largest factor will be the number itself. So what you should write here? The largest factor of any number is the number itself. You can complete these questions in your textbook itself. Now question B, the smallest multiple of 5 is dash. So what are multiples? Multiples are obtained when the given number is multiplied with numbers such as 1, 2, 3 and so on. So what is the smallest multiple of 5? 5 ones are 5. So let's write 5 here. Now question C, the number of even numbers between 1 and 100 is. So what are even numbers? Even numbers are those which end in either 0, 2, 4, 6 or 8 and they are divisible by 2 as well. So you write down all the possible numbers, all the possible even numbers between 1 and 100 in your notebook and count them and write the number here. Similar is the case with the next question. The number of odd numbers between 1 and 100 is. So odd numbers end in either 1, 3, 5, 7 or 9 and they are not divisible by 2 as well. So you write down all the odd numbers between 1 and 100, count the number and write it over there. Now the smallest and the largest factors of 56 are. So we know for all the numbers 1 is a factor and the number itself is a factor. All the other factors will come in between 1 and the number itself. So the smallest factor will be 1 and the largest factor will be the number itself. So with that in mind, the smallest and largest factors of 56 are 1 and 56. 1 being the smallest and 56 being the largest. Clear? Now question number 6. Find the HCF of the following pairs of numbers. The first question A, 28 and 62. So what is HCF or the highest common factor of 2 or more numbers? HCF or the highest common factor of 2 or more numbers is that number or the largest common factor which will divide all the given numbers completely without any remainder. So first we have to find out the factors of the given numbers. So the numbers here are 28 and 62. Which are the factors of 28 and 62? Factors of 28 are 1, 2, 4, 7, 14 and 28. Right? 1 into 28 is 28, 2 into 14 is equal to 28 and 4 sevens are 28. So these are the numbers which can divide this 28 completely without any remainder, or these are the numbers that can be multiplied together to get the number 28. Similarly, we have the factors of 62 listed here. Factors of 62 are 1, 2, 31 and 62. 1 into 62 equal to 62 and 2 into 31 or 31 into 2 is equal to 62. Now, do you see the common factors between them? The common factors between 28 and 62 are 1 and 2. And which is the highest among these common factors? It is 2, right? So, the highest common factor or HCF of 28 and 62 is equal to 2. Similarly, you have to find out the HCF of the other pairs as well in the same question. Let's move on to the next question. Question number 7. A piece of cardboard measures 140 centimeter. It has to be divided into 35 equal pieces without anything being left. See if it's possible. So, what data is given in the question? We have this cardboard piece and it measures 140 centimeter on each side. We are asked to check if it is possible to cut 35 equal pieces out of this one cardboard piece. So, how do we approach this question? We can, if it's possible to cut 35 equal pieces, then there won't be anything left, right? Means if 140 is divided by 35 and we don't get any remainder, or if the remainder is 0, then it should be possible. So, let's solve this question in a different way without actually dividing. Let's look at the factors of 140 and 35. So, the factors of 140 are these 1, 2, 4, 5, etc. These are the factors, and we have the factors of 35. And you see the common factors between them. The common factors are 1, 5, 7 and 35. And which is the highest among this? The highest common factor of 140 and 35 is equal to 35. And what is highest common factor HCF? HCF means the largest number which can divide the given numbers completely without any remainder. Means if HCF is 35 or HCF of 140 and 35 is 35, it means 35 can divide both this 140 and 35 completely without any remainder, right? Means 140 is divisible, completely divisible by 35. So, we can conclude that it's possible to cut 35 equal pieces from the cardboard piece measuring 140. There will not be any remainder or no piece will be left. Now, let's see the next question. Find the numbers between 45 and 75 that are divisible by both 5 and 10. So, we have learned the divisibility rules of 5 and 10. For a number to be divisible by 5, the ones digit should either be 5 or 0. And for a number to be divisible by 10, the ones digit should be 0, right? So, let's see the numbers between 45 and 75 that are divisible by both 5 and 10. So, let's first see the numbers divisible by 5. The numbers between 45 and 75 that are divisible by 5 are 50, 55, 60, 65 and 70. And divisible by 10, the numbers ending with 0 are 50, 60 and 70. So, the numbers which are divisible by both 5 and 10 will be the numbers which are divisible by 5 and those ending with 0 or the ones digit is 0. So, which are those numbers? The numbers divisible by both 5 and 10 are 50, 60 and 70 from these numbers. Clear? Now, let's see the 9th question. Find the numbers between 83 and 91 that are divisible by 2. So, we have learned the divisibility rule of 2. For a number to be divisible by 2, it should end in either 0, 2, 4, 6 or 8, right? They should be even numbers. So, let's see the even numbers between 83 and 91. So, which are the even numbers between 83 and 91? They are 84, 86, 88 and 90, and these are the numbers which will be divisible by 2 between 83 and 91. So, now the last question, question number 10. List any 4 factors of 90 and the first 5 multiples of 13. So which are the factors of 90? 90 can be 1 into 90, 2 into 45, 3 into 30, and we have many factors for 90, right? We have more than 2 factors for 90, and these are the factors. You can write any 4 factors because it's mentioned here. You can write any 4 factors from the list, and you have to write the first 5 multiples of 13. First 5 multiples means 13 into 1, 13 into 2, 13 into 3, 13 into 4, and 13 into 5. So we have the multiples here. 13 ones are 13, 13 twos are 26, 13 threes are 39, 13 fours are 52, and 13 fives are 65. So there we have the 5 multiples of 13 listed. So I hope you all are clear with the concepts. Still, go through all the concepts we learned in this class, learned in this chapter once again, and make sure you all get thorough with the multiplication tables of 1 to 10. The first 10 multiples will be enough. You can make small charts and you can stick it somewhere in your house, but please go through the tables, all the tables every single day. Revise the tables every single day and you'll get thorough with it very soon. So get thorough with the multiplication tables, go through the concepts we learned in this chapter once again. Then you have to do a worksheet which is in page number 78, and also there are 2 activities listed in page number 76 under the heading activity and maths lab activity. So please go through those questions as well, and that's all for today. We'll meet in the next class. Until then,